In the past week, I had a request for help on an integration problem similar to the one that you see on your screen. And it's not exactly the same, but very close. And it said to find the indefinite integral of x plus 3 times the square root of 2x plus 3 dx. And the method for solving this was by integration by parts. If you look down towards the bottom of your screen, you can see that I've simplified that integral. And can you tell what I did to simplify that? All I did was rewrite the square root of 2x plus 3 as 2x plus 3 to the 1/2 power, which is the same thing. And now we have rational exponents rather than a square radical sign, which is always better when you're solving integrals, to have rational exponents rather than radical signs. So we are to use integration by parts, and I've written out what the integration by parts formula is. If we have the integral of u v prime dx, then that is equal to uv minus the integral of u prime v dx. And perhaps you've already memorized this formula. It's a very good formula to memorize. If you haven't, it's also possible to derive this formula. But for the sake of brevity in this video, we won't derive it. We'll just assume that you've memorized it. One of the more difficult parts of doing integration by parts is that you must determine what should be u and what should be v prime. Well, there's a couple of guidelines to go by, and I've written those out in green. The first thing is that you must be able to find v. In other words, whatever you've selected for v prime, you must be able to find the antiderivative of that. And I think you can see that for both x plus 3 and for 2x plus 3 to the 1/2 power, we can find antiderivatives for both of those. So the first criteria is met. No matter what we pick for v prime, we'll be able to find v. But for part 2, it's nice that if u prime is simpler than u. And so let's say that we pick u to be x plus 3. Well, then u prime would just be 1. That's definitely simpler. Meanwhile, with the 2x plus 3 to the 1/2 power, u prime is not simpler. Matter of fact, it looks a little more complex. It'd be 1/2 times 2x plus 3 to the negative 1/2 power, and then times 2. So right there, we can determine that it is probably better to pick u to be x plus 3 and v prime rather, to be 2x plus 3 to the 1/2 power. So let's write that down. So u is equal to x plus 3, and then the derivative of that, we just said that u prime would be equal to 1. And v prime now is going to be equal to the other factor, which is 2x plus 3 to the 1/2 power. Okay, our next task is to find the antiderivative of 2x plus 3 to the 1/2 power, and we could probably do u substitution, although we're already using u, so maybe it'd be something like w substitution. But instead, let's guess as to what the antiderivative is. And I'm writing down 2x plus 3 to the 3/2 power, thinking that if I use the power rule, I'll get 3/2 times 2x plus 3, 2x plus 3 to the 1/2 power, and at least I'll have the 1/2 power that I need, and then I'll have to use the chain rule, so it'll be times 2. And simplifying this, I get v equals 3 times 2x plus 3 to the 1/2 power. And so my guess wasn't quite accurate. I wanted to get 2x plus 3 to the 1/2 power, but no constant 3 in front of that. And so I'll need to take 1/3 of what I have, and then I'll have the right thing. And so I need to go all the way back up, and so v must be equal to 1/3 of 2x plus 3 to the 3/2 power. If I take the derivative of that, I certainly get the 2x plus 3 to the 1/2. Okay, next step is to write this out now. So the integral of our original was x plus 3 times 2x plus 3 to the 1/2 power. So that's our u and our v prime. And then that's equal to uv, and u was, or is, x plus 3. And v is 1/3. V is 1/3 times 2x plus 3 to the 3/2 power. And then we're to subtract the integral of u prime, and u prime was equal to 1 times v, and v is again 1/3 times 2x plus 3 to the 3/2 power dx. Okay, and you can see that there's our u, there's our v prime, there is u, there is v, there's u prime, one was u prime, and v, and there's v again. Okay, so it's in the proper form. The next step is to do some simplification if we can, and I see that we have 1/3. Why not bring that out in front? 1/3 times x plus 3 times 2x plus 3 to the 3/2 power. And then if you look within our integral, you can see that we have a 1/3 in there, and so we can take that constant 1/3 outside of the integration sign, and we have 2x plus 3 to the 3/2 power dx. Now we need to take the antiderivative of 2x plus 3 to the 3/2 power, and we'll use the same method that we did before. We'll take a guess at what the antiderivative is and take the derivative of that and see if it truly is the antiderivative. And so our guess will be 2x plus 3 to the 5/2 power, because we know by the power rule that that'll be lowered to 3/2. And so when we take the derivative, we get 5/2 times 2x plus 3, and then using to the 3/2 power, and then using the chain rule, we get times 2, and simplifying that, we get 5 times 2x plus 3 to the 3/2 power, which is not quite what we want. We don't want the 5 in there, so let's multiply by 1/5 all the way up, so that the antiderivative then must be 1/5 times 2x plus 3 to the 5/2 power. Now, writing all that, knowing that, and writing everything else in, I'm just copying the first part of the problem, and 1/5 times the 1/3 that we have there is 1/15, and our antiderivative we said was 2x plus 3 to the 5/2 power, and since this is an indefinite integral, it's plus c. That's all the time we have. See ya.